shameless plugs now for commercials. This is the shameless HA plugin slot. We're HighAvailibility.com. All we do is high availability. And for ZFS and OpenZFS, we supply high availability sort of middleware to make ZFS highly available. History-wise, we've been going since 1995. We started off predominantly on Solaris and Spark platforms, very much really kind of the whole stack. So we'd make applications highly available, and underneath that, typically a database and storage. We think we were the first commercially available HA solution on Unix, and we've been running really for about 19 years. The product has a lot of history, and it's been optimized over that time. The original design was to keep it simple, so it's very Unix-like and fits very well with most platforms. Over the years, we've had a very global install base of many thousands of enterprise deployments, predominantly on Solaris. The core capabilities of the product is it's a general HA product. It's not limited to 2 nodes. So we can provide a framework really that supports up to 256 services across nodes of 2 to 64 clusters. We support pretty much every Unix platform. Historically, we've done HPUX and AIX as well. But most of our install base is Solaris and now Open Solaris and all the variants therefrom. We also provide an application framework to support many other applications, which I'll come on to. All sorts of other capabilities there, which hopefully are self-evident. Particularly for ZFS, though, we are the HA cluster choice for quite a few of the vendors. We are the HA plugin for Nexenta and CoRaid and a few others. And to date, we've deployed over 2,000 ZFS clusters. We do a lot of work with the block and file services, so sort of high availability support for Comstar and Alua and all the other sort of protocols. And we've implemented quite a sophisticated disk ring fencing mechanism to protect data and make sure split brain scenarios don't occur. We're integrating as well fault management so that we don't just fail over in the event of a system fail, but if temperatures are getting too high or disks are beginning to wear out, there's a lot of work going on there. And also we've done a lot to optimize import and export times. That's always the kind of the biggest problem. If you've got quite complex ZFS pools, the import times can be longer than more simple pools. So we've done a bit of work there to optimize that. And also system freezes. Sometimes systems don't just fail and go cold. They stop and then come back. And from an HA perspective, if you think another system's failed and then it comes back, you can get into a split brain scenario. So we have a lot of mechanisms to protect against that. And we have seen systems in the field, particularly high memory systems, that can just freeze intermittently depending on the platform. So we put a lot of protection into safeguard against that. Just to give a very typical overview of what a sort of typical 2-node topology would be for RSF. Here we've got 2 nodes in kind of active-active capability, where the primary node is running one application or storage pool, and the second one also. And the kind of interfaces here are the VIP per node that guides the users to the relevant machine. So in this typical configuration, we've got 2 storage systems that are mirrored, and we have a number of heartbeats between the 2 nodes that tell us about the health of the cluster. It's worth pointing out here that the heartbeats are not just a ping, it's actually a complete exchange of information about the state of the entire cluster. So it's not just a low-level network ping. The 3 different heartbeats we show here, the serial heartbeats are literally a serial cable using a low-level RS-232 interface, and disk heartbeats. So the idea of removing all single points of failure, if we lose the network and we lose the network heartbeats, we're protected by serial or disk heartbeats. And whilst you don't have to have them all, we recommend at least 2 different heartbeat mechanisms to safeguard against that. So in the event here of a system failure, let's say the primary node on the left fails, the system on the right says all the heartbeats have gone, I'm going to start the service that was running on the primary node, and now we've got 2 VIPs representing both services running on node B. So the way we've implemented it for ZFS is the services, which are sort of normally applications of the database and file store under. In these kind of topologies, they're essentially ZFS pools. That you can have multiple pools per service or just a single pool. The nodes are really appliances, although they can be doing more than that, and the various network services that we also fail over. Other applications can be added, and I'll come on to that. Removing all the single points of failure. This is obviously a single point of failure, and this is one of our custom sites in the UK that burnt down. So taking high availability away from a single point of failure, which is typically a data center. Here's another example, which is site-to-site topology. So on the left, we've got site 1, which has got a storage array with, let's say, 2 servers. And site 2, we've got another array with a third server. On the pools, on the storage arrays, we've got 4 pools, which steadfast pools, which is labeled A, B, C, D. And each system is running a combination of those pools. So here we've got a WAN connection between the sites, and let's assume we're doing ZFS mirroring across there. Now, we don't really care how you do that, whether it's some sort of replication or whether it's using ZFS mirroring. Let's assume as well both sites have outside network connectivity, so that there's, rather than just a private WAN between the sites, they both have internet or some sort of VPN connection outside of that. So here in this example, we've got server 1 that is running pool A, and showing on the left here is the VIP live on server 1. And let's say server 2 is running pools B and C as 2 separate services. And over here on site 2, we've got a pool D that's being managed here. So the topology here with the heartbeats is that all 3 servers can see each other via the private network, if you like, and they heartbeat between them. In this setup, we've also got a disk heartbeat, so all 3 systems can also communicate via the disks as well. Now, typically, this means that the disk connections are also going over the same WAN connections to the network, so there is a single point of failure there. So what we've implemented fairly recently is the idea of a stretch cluster using cloud-based heartbeats. So in this example, we have these relay stations that are running anywhere outside the network, and we set up kind of relayed heartbeats via this connection as well. So under normal service, we've got pool A running on server 1, B and C running on server 2, and D on server 3. And let's assume we have a failure here on system 2 has crashed. So server 2's failed, and the B and C VIPs are no longer responding. So server 1 and server 3 detect this, but we're going to restart the service on server 1 because we don't want a geographical failover when we have a system locally there. So we have this idea of site bias that says, although both server 1 and server 3 are capable of failing over, we want it to fail over to server 1. So server 1 is now running the 3 pools. Assuming now that we have a failure in site 1 and server 2 is still down, let's assume that the network has failed at site 1, so it has no external network access, but server 1 is still alive. So server 2 is already down, and site 1 experienced the complete failure. Server 1 loses contact with server 3 via all heartbeats, and it can't see the outside world. So node 1 says, well, I've lost contact with everybody else, and I can't see the outside world either, so I assume I've been segmented. I'm going to shut my services down cleanly. At the same time, site 2 and server 3 says, well, I've lost contact with server 1 as well, but I can see the outside network, so I'm going to start those services that have now failed. And in this topology, we're going to assume that we're going to have a service C, but we don't want that to fail over to site 2, because that's just a locally delivered service. So it's just to give an idea of the flexibility we can have. So in addition to the pools, we also have an application framework that says, rather than just failing over the storage, we can fail over applications as well. So in an example here on pool B, we've got a MySQL database. On pool C here, we've got a web server. So the agent framework also monitors the health of the application. So with MySQL, for example, we have a heartbeat mechanism through the database itself. And if we can't write to the database, we can't read from it, we assume we failed. And we can fail over. We can either try and restart that service locally or trigger a failover to another side. So I won't read through all these, but just some of the key features really. The idea is it's not just a 2-node cluster with active-active or active-passive. It's much more generic than that, and the flexibility, is pretty vast. Some of the key features for ZFS, again, all the sort of common protocols. There's various other bits and pieces in there which I can talk about if anybody wants to sort of ask any questions later. So the opportunity here for end users, if you're building your own HA appliance, sorry, your own ZFS appliance and you're looking for high availability, then we'd be happy to work with you and show you what we can do. If you're a vendor and you're looking to build your own white labeled ZFS appliance and you're looking for an HA option, we provide the white label kind of situation too, like we do with Nexcenter, Curate and others. And we would say be happy to work with you on evaluations and show you the power. If you have any questions, I can answer them now or any time throughout the day.
Any questions for Gren? No?
Sure.
Yeah, so I've just got one question, and that's how do you market ZFS, and what kind of response do you get from people that are more familiar with the traditional SANs?
Well, I suppose we don't specifically market ZFS. We do really sell our products not just on ZFS. It's most file systems under Unix, but I'd say probably 99% of our inquiries now are around ZFS, and that's where we concentrate our efforts. So we don't sell HA. We don't sell ZFS. We only sell HA. Just the space we're in. That's where most of our inquiries and work comes from.
Of those ZFS inquiries, how does the breakdown of Solaris ZFS versus OpenZFS?
Okay, well, most of our inquiries tend to be on Illumos and Illumos-related operating systems. We get the occasional inquiry on Linux and BSD, and we do still do quite a lot of Solaris deliverables as well, but I'd say the vast majority now, probably 80–90%, are Illumos-related.
Actually, I've got another question. Based on you said that, so people coming to you for high availability products, is there a particularly sort of the market segment? Is there a sort of trend in the market segment of who's actually looking for higher availability?
I think most of our inquiries tend to be from people building their own appliances. Maybe they've used some of the branded products out there and decide that they can build their own because it's mostly based on open technology. So I would say a lot of the direct inquiries we get are more of that ilk, and the rest really are vendors looking for an HA piece for their own offering. So it's a bit of both really. We've got a few sort of POCs out there at the moment that fit both those categories. Yeah.
Cool.
Okay, thank you.
Thanks very much, Gren. Luke? I was going to introduce now Luke Marsden. You saw him earlier on, but he's now going to talk about his company, Hybrid Cluster. And I'll just load your presentation for you.